today we're going to talk about projectile motion. We start off with the position function, v initial cosine alpha times t in the I direction, and then h plus v initial sine alpha times t minus 1/2 gt squared, where g represents gravity and alpha represents the angle upward from 0. So our example problem is you shoot a rifle from 200 feet with an angle of 30 degrees and an initial velocity of 1,500 feet per second. And we would like to find at what time the bullet hits the ground, at what distance the bullet hits the ground, and the max height reached by the bullet. So to find the first one, at what time the bullet hits the ground, we first have to start with putting in equations for what the I and j represent. So the I represents everything traveling in the x direction. So as the bullet travels in the x direction, we would like to find how much range from where it started to where it will land eventually as time goes on. So to find x, we look at the I function, and we have our v initial, which was 1,500 feet per second. And then we have cosine, and our angle is 30 degrees. So cosine of 30 degrees, and this will give us 750 root 3t. So this is our x function. This will be a function as time goes on in the x direction. Similarly, we can do this for the y direction, everything for the j. So we have h, which is our initial height of 200 feet. And then v initial sine alpha, so that was 1,500 times sine of 30 degrees times t minus 1/2 g, but this is feet per second, so it's 32 feet per second squared, and then all of this times t squared. This will give us 200 plus 750t minus 16t squared. We can use these functions to find out our when the bullet will hit the ground, because we can just find that when our y function is 0, it's when the height is 0, and so we can equal this entire function to 0 and find when t hits the ground. This is 47.1 seconds. Using this time that we found when it hits the ground, we can just plug this t into our x function to find that when it's at 47.1 seconds, as it has hit the ground, we can find how far from our original point it is. So we plug that in and we get 61,185 feet. And we get this by plugging this number into the t right here. And for max height of the bullet, we find this by using the first derivative of our y function, because the first derivative of a position function is the velocity. And so if we know the first derivative of this function is going to be 750 minus 32, we can now find when this equals 0, because it's a projectile motion. When it equals 0, it will be at the max height, and velocity will be equal to 0. And that's when we can find when it actually reached the top. T equals 375 over 16. And we plug in this t into our original y function right here. And we can find the position in the y direction at the max height time. and we get a max height of 8,989.1 feet. Is the max height the bullet reached before it started falling down towards the earth. Thank you.